I'm Anil Kumar. Welcome to my series on integration. We are taking applications based on displacement, velocity, and acceleration. Two objective type multiple choice questions for you. Question number 3. The instantaneous acceleration of an object is a of t equals to minus 5 centimeters per second square, where t is greater than or equal to 0. What is the change in velocity from t equals to 2 seconds to t equals to 5 seconds? Question number 4. A particle is moving along the x-axis so that at time t in seconds, its velocity v of t in centimeters per second is given by v of t equals to 2t square minus 3t plus 2, where t is greater than or equal to 0. Its initial position is 5 centimeters to the left of origin. So that means at t equals to 0, the position is s of t at 0 is minus 5. What is its position after 6 seconds? The choices are given to you. You can pause the video, answer the question, and then look into my suggestions. Okay, so the very first one here, we are given the acceleration a of t, which is a constant minus 5, right? We want to find the change of velocity, right? So change of velocity is integral of acceleration. So velocity basically is integral of acceleration, correct? So in our case it is minus 5, so we'll do integral of minus 5 dt, and so we get the velocity as equal to minus 5t plus c. Now constant c we can find from the given position. So it says the instantaneous acceleration is this much. What is the change in velocity at these two times? So when they want change in velocity, we don't need to find c, right? And even otherwise you can't. Okay, so now let's find the change in velocity from t2 to t5. That means v5 minus v2 is what we're looking for, correct? So substituting those values here, we get minus 5 times 5, right? That c will cancel. You may write plus c, okay? Take away. Writing 2 here in this equation, we get minus 5 times 2 plus c. So when you calculate this, minus 5 times minus 5 is minus 25. C and c cancel. And this minus and minus becomes plus 10. So the change is minus 15, right? So that is the change. So option A is the right option, correct? So that is how we are going to find the answer. Question number 4. A particle is moving along the x-axis so that at time t in seconds, its velocity v of t in centimeters per second is given by, let's write down, so velocity is given to us as 2t square minus 3t plus 2, where t is greater than or equal to 0. Its initial position is, so we are also given at t equals to 0 is s is equals to minus 5, right? Left of origin. What is the position after 6 seconds? Okay, so we need to find at t equals to 6, what is s, right? That is what we need to figure out. Okay, so s is the integral of this. So we can find displacement by doing integral of the velocity function. So let's integrate this with respect to time, correct? So we'll integrate this with respect to time. What do we get? So 2 times t to the power of 3 over 3 minus 3t squared over 2 plus 2t, right? That's what we get, plus a constant c. Now to find the value of constant c, we can use what is given to us. So at t equals to 0, s is minus 5. So if I write 0 here, so s of 0 is equal to minus 5, right? So minus 5 is the value of, this is all 0, is the value of c. So you can get the expression for s of t, right? So s of t is equal to 2 by 3 t cube minus 3 by 2 t square plus 2t minus 5. So that is the expression for displacement. Now what is the position after 6 seconds? So we'll write 6 here and calculate, right? So S of 6 is basically equal to 2 over 3, 6 cube, right? So we have 6 cube minus 3 over 2, 6 square, right? Plus 2 times 6 minus 5, correct? So if the calculator is allowed, you can definitely use calculator and figure this out, right? So otherwise, what do we have? So you can say it is 6 square is 36 times 2, 72, and 3 goes 2 times. So 72 and 2 is 144, correct? So we get 144 here minus 6 square is 36, half of 36 is 18, and we have to multiply 18 by 3, right? So we have to multiply 18 by 3. 3 times 8 is 24, 2, so we get 54 here. Plus 12 minus 5, right? That's what you get. So it's a big number. So we have to take away 12 from these numbers, okay? So it is, let's add 12 first. 6, 5, 1, take away 59. Okay, so when you take away from 16, you get 7, and then you get 9. So 97 is the right answer, correct? So 97 centimeters is the position at 6 seconds. So I hope you understand how, with the help of integration, we found in the first case the velocity and in the second case displacement at a given point. I hope that helps. Feel free to write a comment, share your views, share your questions with us. If you like and subscribe to our videos, that'd be great. Thanks for your time and all the best.